In this last video on redox, we're going to look at how to write redox equations. First of all, we've got to look at writing equations for one element, and that is called a half equation. So, and obviously when you have a half equation and another half equation, then you can write the full stoichiometric equation. Okay. Now there's some rules we have to follow when writing redox equations. The first is only one element in a half equation changes its oxidation state and hence its oxidation numbers. The half equation must balance for atoms, and it's the same for any equation. Also, if the equation must balance for charge, and electrons will be used to balance this. If we've got an uneven number of oxygens in our equation, we can balance that up using water as a source of oxygen. And then any surplus oxygen is converted into water by reaction with H+ from acid. Okay, so let's have a look at this first example. This first example, we're trying to write the half equation showing bromine being converted into bromide ions. Okay. So the first thing we must do is balance for atoms. Okay, so we're going to balance for bromine, and we're going to do that by multiplying. We're going to do this by multiplying by 2 here. So now we've got two bromines on the left hand side, 2 bromines on the right hand side. The next thing we do is balance for charge. Okay, so we've got overall on the left hand side a neutral charge or a 0 charge. On the right hand side we've got 2 negative ions because we've got 2 bromides. Okay, so we need to do this. So we need to balance the left hand side of the equation by adding 2 electrons. And so just writing 2 electrons plus your bromine gives you your balanced half equation. Okay, because we've got 2 bromines, 2 bromines. Overall a charge of -2, overall a charge of -2. So that's the first example there. Okay. The next example is a little more complicated. Okay. Let me scroll up. The second example here is manganate ions being converted into manganese 2+. This is a very common equation to see in redox. Manganate ions are very powerful oxidants. So, first of all, let's balance for atoms. You see, we've got 1 manganese on the left hand side, 1 manganese on the right hand side, so it's balanced. Okay. The next thing is to balance for the oxygen atoms. Now we've got 4 oxygens on the left hand side, but here we've got no oxygen atoms. So we balance it up by using 4 water molecules. So we now balance for manganese and we now balance for oxygen. But we've now created a problem by introducing another element, which is hydrogen. And we've now got 8 hydrogens on the right hand side. So to compensate for that, we add 8 protons here on the left hand side. Now you can see that we've got our atoms are balanced. So 1 manganese, 1 manganese, 4 oxygens, 4 oxygens, 8 hydrogens, 8 hydrogens. Now let's look at the charges on either side. Here we've got +7, and overall here we've got +2. And that's because we've got a -1, +8 positives gives +7, +2, and 4 neutral molecules, that's overall +2. So to balance off the charge, we add 5 electrons to the left hand side to bring this charge down from +7 to equal +2. And so overall our equation becomes manganate ions plus 8 protons plus 5 electrons gives manganese 2 plus 4 water molecules. As we can see, 1 manganese, 4 oxygens, 4 oxygens, 8 hydrogens, minus 1 plus 8 minus 5 equals plus 2, plus 2 plus nothing equals plus 2. So that is a balanced equation. One more example here. So again, feel free to pause the video and to do this one yourself. So here we've got a nitrate ion being converted into another nitrate ion. This is nitrate 3. This is nitrate 5. The old-fashioned name for this was nitrite. Okay, so the first thing we've got to do is check, are we balanced for atoms? We've got 1 nitrogen, so that's balanced. But we've got 2 oxygens on the left-hand side and 3 oxygens on the right-hand side. So we need to balance for oxygen. And we do that by adding a water molecule to the left-hand side. So now we've got 3 oxygens on the left-hand side. But again, we've created a problem by introducing a new element. So we need to balance these 2 hydrogens by putting 2 hydrogens on the right-hand side. And that's what our equation becomes. Now we look at the charge. We've got minus 1 plus a 0 is minus 1. We've got a minus 1 plus 2 positives, 2 pluses, that equals plus 1. Okay. So again, to balance these out, we need to add electrons. This time we're adding them to the right-hand side of the equation to take our charge down to minus 1. And so our final balanced equation is NO2 minus plus H2O gives NO3 minus plus 2H plus 2 electrons. And it's completely balanced because it's got 1 nitrogen, 2, 3 oxygens on the left hand side, 3 oxygens on the right hand side, 2 hydrogens, minus 1 charge, minus 1, plus 2, minus 2 is a minus 1 charge. Okay? So that's how we write half equations. The next step is to write a balanced equation. So add the 2 equations together. But you can't add your half equations until, so you can't create your full equation until you wrote both half equations. Okay, and the important thing is that before you can add each half equation, they must have the same number of electrons in them. Okay, so looking at these 2 half equations here, for the reaction between dichromate ions and ion 2, you can see that the dichromate requires 6 electrons and the ion 2 releases 1 electron. So, to give us an equal number of electrons, both equations, we must multiply the bottom equation by 6. So, that gives us 6Fe2 plus gives 6Fe3 plus 6 electrons. When we add the 2 equations together, the electrons cancel down. And then you look to see if any of the terms can cancel down. In this case, they do not. So our final balanced equation is dichromate plus 14 protons plus 6Fe2 plus 2 chromium 3 pluses, 7 waters plus 6Fe3 plus. So this is a completely balanced equation in terms of atoms and charge. Okay, thank you for watching.